probably easier. Okay, so we are going to do the evens. We're going to go through all the evens in order on the review sheet. So, that means starting with, oh, and look, no names on the board. Woo! First time that happened in a long time. All right, so question number 2, we're doing the evens. So we have to find the period of this. Now, we have done this before. We are not going to be frightened of that equation. Now, an equation like that's going to show up later, for sure. But right now, all we want to know is the period. So how do we find the period? 360 divided by whatever that number is. In this case, it's a 5. So you won't have a calculator for this. You're going to have to divide that on your own. But 360 divided by 5 is 72. So the period is 72. To find the period, it's 360 divided by that number. All right, now we're looking at this equation. Now that is a cosine, doesn't matter. Sines and cosines are handled exactly the same. The difference, of course, is in the shape. We'll talk about that later, but everything about them is the same. So we want to know, what is the range? So the range is high point to low point. If we were going to graph this, how far down would we go? How far up would we go? The equation tells you. What are these labels? Oh my. -4 to 4, that's your amplitude. So your range is -4 to 4. Now remember, guys, this is all review. So I am not teaching you anything tonight. You are going to have to go back and review your notes. Go back and find the old videos. This is all chapter 4. I'll try to tell you what chapter we're in at least. All right, now this is chapter 6. This question is, it says we've got these 2 vectors, and we are going to find their dot product. I just did this in some class today. How do we find the dot product? Multiply the x's, multiply the y's, and add them up. So -1 plus -8, the dot product is -9. We multiply the x's, multiply the y's, add them up. All right, this question is chapter 8. It's what we just did. That's a parabola, and all we want to know is, what's the vertex? What's the vertex? 5, 3. That's it. The vertex is 5, 3. Jim?
Do you have another copy of the packet for that?
Yeah, this is the only packet we've had, and I actually emailed it to you. So if you have your iPad, you can pull it up.
Sure does.
Yeah.
This is it.
Hi, Mother.
Oh, you just took something?
He took some.
No. Those are the old ones, Brandon. You don't just come in and start grabbing stuff out of somebody's personal stuff. Well, apparently you are interrupting. There you go.
Okay. Well, I'll just go die. Thank
No,
you.
don't do that. You got more math to do. Okay. All right, so there's number 8. All right, so number 10. Find the sine of 45.
I just realized that was on video.
This is no calculator. The sine of 45. Okay?
Oh. Fine.
How do we do it? No calculator. This is out of chapter 4 also. We draw a triangle. It's going to be special. If you're not allowed to use a calculator, it's going to be special. It's a 45-degree angle, which means the sides are what? 1 root 2, right? And we want to know the sine, so the sine will be opposite over hypotenuse, which you'll rationalize to root 2 over 2. Boy, they're easy. If you know what you're doing, they're pretty darned easy. All right, number 12. Now we're going to simplify. This is another one out of, actually this is out of chapter 5. Secant times cotangent. All right, what's secant? What'd you say, Robin? It's reciprocal of the cosine, so it's 1 over cosine. What's cotangent?
It's 1 over tangent.
Well, it's reciprocal of tangent, but we don't use tangent. We got to use sines and cosines. So what would it be?
It's sine over cosine.
Tangent is sine over cosine.
Cosine over sine.
So cotangent will be cosine over sine. That's all on your gold sheet. So if you still have your gold sheet, you should probably review that a little bit. Now, the cosines will cancel, and we're left with 1 over sine. This will be a multiple choice question. So 1 over sine might be what's written as a choice. But what else could be written as a choice? Because 1 over sine can be written a different way. What's the reciprocal of the sine? 1 over sine. One over sine is cosecant. Ooh, guys. You can afford to forget a few things, but not that much. We gotta get that gold sheet out and start reviewing that for sure. All right, 14. We have a hyperbola, and we want to find the vertices. Now remember, hyperbolas open up or down or sideways. So we're going to have to figure out which way this, do you know which way this opens? Up and down. But to get me started, I probably should plot my center first. And my center will be where?
-2,
-2, -1, very good. And you said it's going to open up and down. So the hyperbola, without going through and drawing all the box and all that stuff, it's going to look something like that, right? These are the points you're looking for. Those are the vertices. Well, that's easy. I just have to know how far up and down I went. How far up and down did I go? 5. So if I start here and go up 5, I'm starting at -1, going up 5. Won't I be at -2, 4? And if I go down 5, I'll be at -2, -6. And those are my vertices. That's all. You don't have to do asymptotes and all that stuff. You just have to find the vertices. So you got to remember what the vertices are. Got to remember which way it opens. Then it's easy. All right, 16. So we know the cosine is 4/5. And we want to find the sine. Okay. What's pi over 2? Let's change that. Pi over 2 is 90. So theta is our angle. What is this telling me about my angle? It's in between 0 and 90, right? And if I'm in between 0 and 90, then I must be in quadrant 1. All right, so tell me about that triangle. I have no idea what this angle is. That's theta. I don't know what that is. Do I know anything about the triangle? Adjacent over hypotenuse. So I know adjacent is 4 and hypotenuse is 5. And then I can find the other side, Pythagorean theorem. So we'll call it y. So 4 squared plus y squared equals 5 squared. And 16 plus y squared equals 25. So y squared equals 9 and y must be 3. Now I want the cosine. Oh no, I want the sine. I know the cosine. I want the sine. So what's the sign?
3 over
3 over 5, opposite over hypotenuse. So the key there is to draw the picture, find the missing side, and then you can answer the question. All right, so that was 16. Now I'm on 18. I have 1, -1. That's my x and my y. And I'm going to find the polar coordinates. Polar coordinates are r and theta. Now this is no calculator, so somehow I have to figure out r and theta without a calculator. So how do I start? How have I done every problem that I've done so far? I've drawn a picture. So I'm going to draw a picture of the given. So over 1, down 1. There's a picture of the given. When in doubt, butterfly bow tie. Now from that, you should be able to figure out what r is. This is r. What's r going to be? √2. And you certainly can tell me how big this angle is.
45.
45. But remember, this is theta. So 360 minus 45, so it's going to be 315. If your triangle is not in quadrant 1, then you know 2 things. Something in the picture is going to be negative, and the angle has to be modified. So add 180, subtract from 360, whatever you have to do. If you're not in quadrant 1, you're going to have to modify your angle. Now, 20 is exactly the same problem, except we need polar form, which is RCIS theta. So instead of polar coordinates, it's polar form. Now, that's the same R and the same theta. So I'm going to do all the work exactly the same. So I have negative 2√3 and negative 2? Negative 2√3 and negative 2. So my picture looks like that. Alright, so I'm going to find the R. So what will I do to find the R? Pythagorean theorem. So that's going to be 2√3 squared plus 2 squared equals R squared. When you square, remember this is no calculator. When you square 2√3, you have to square both pieces. What's 2 squared? 4. What's √3 squared? √3 squared is 3. So you have 4 times 3, so this is 12. Plus 4, which is 16, so R is 4. Now this one's a little tricky to tell the angle, but be smart about it. You know that if I am not allowing you to use a calculator, what do the angles have to be? Either 30, 60, or 45, right? Those are the only ones we do without a calculator. So looking at that triangle, do your beady little eyes spot that? Yeah. What kind of triangle do I have here? 30, 60, 90? Right? And if that's the √3, shouldn't this be the 60 down here? So what does that make this one? The 30. Now, R is 4. We figured that out. Theta is not 30. Remember, if you're not in quadrant 1, you have to adjust your angle. So this is theta. How big will that be? 210. 180 plus 30, 210. So that is the answer to the question. All right, that was 20. So now we're ready for 22. All right, I just did this like an hour ago with some class. Must have been E, we just did this. Does anybody know how we get, this is the vector form of the line. How do we get from the vector form into the like regular form of a line? What? We kind of, I think you know what you mean. I'm actually the words you're using. So we break it up. So what does x equal? -1 plus 3t, right. What does y equal? 3 plus t, perfect. So everybody's good with getting it split up. Those, by the way, are called the parametric equations, and they will be part of a later question, but they're not this question. This question says, write that in standard form. That means no t's. So how do I get rid of the t's?
Elimination.
I could eliminate or substitute, right? I get rid of them the same way I get rid of everything I don't need. I either eliminate it or I substitute it out. So, if you do substitution, subtract the 3, y minus 3 equals t. So x equals -1 plus 3y minus 3. So x equals -1 plus 3y minus 9. 3y minus 10. Now that will not be in the answer blank because that's not standard form. So some arrangement of that will be in the answer blank. Okay, multiple choice question. So another arrangement of that might be x minus 3y equals -10. Do you see what I'm talking about when I say that line can be written in different ways? What I don't want you to do, kids, is do all that work and then say none of these. That's an option. Because you don't see this in the answer blank. You won't see that in the answer blank. You'll see something like this in the answer blank. So take an extra couple minutes and rearrange your answer to see if you can get it to match any of the options. Okay? And of course you're going to show your work on your exam so I can go back and look at even the multiple choice questions to figure out if partial credit is in order. All right, so that was 22. So now we got 24. Oh, wait. 24. All right, so how do I do this? It means magnitude, but I gotta do something before I do magnitude. What do I have to do first? Multiply by 3. So if I multiply by 3, that will give me -3, -6. And now I'll do the magnitude. And how do I do the magnitude? Square the first one, square the second one, add them up and take the square root. Notice that when I square, the negatives disappear. Please don't put negatives in your magnitude. Everything's squared, so it's going to stay positive. So we have the square root of 45, and we always want to break that down if it does break down. I think that one does. It's 9 times 5, so it's 3 root 5. Okay. Now, I crossed out 25 and 26, so I want to do a replacement problem, because on your exam there will be a replacement problem for those since I took those off. So let's do this as our replacement problem. Okay, this is our replacement problem. And what do you think the question is asking? Well, it's a circle, so it's going to say find the center and or radius. So what do we do to find the center and or radius? Blank blank, yep, x, thank you Olivia Piper, blank blank. X squared minus 4x, y squared plus 10y and negative 18, right? So what goes in the first blank? We're going to complete the square here. So we put a 4.
125.
Don't forget both sides. And then this one will be a 25. Remember how we're getting those numbers? We take half of this and square it. Now, this is this. What goes in the parentheses?
X minus 2,
This
y plus 5.
is this, and it's going to be y plus 5. Yep. And then I'm going to add all that up and get 11. So what's my center?
2, -5.
2, -5. And my radius is square root of 11. Again, if that reduces, you want to make sure that you reduce it. All right. Now, 28 is on the exam. We need to know how to do 28. So, how do we do that? Is that the one where we write the 2 columns? Yes, it is. We write the 2 columns. So first column, second column, written right there in order. Now we start right here and we multiply. What are you doing? We multiply and get 0. And then we multiply and get 6. And then we multiply and get 0. And we total those up. And then we multiply and multiply and multiply. And we total those up. And then we get our final answer by doing what? Subtracting 6 minus -2. So the answer to the problem is 8. Remember, that's a no calculator problem. So you're going to have to be able to do that by hand. And you can, it's easy. All right, what's going on here?
Switch. You gotta find the in.
The inverse. We're finding the inverse. Yes, indeed.
Switching 1 and 2.
Okay.
Switch them.
So we start by doing some changing here. So the changes are these 2 numbers switch places. And 0 stays 0, but positive 1 becomes negative 1. Now, a lot of times kids stop here. And I'll be honest, multiple choice question, that's going to be an answer. You're going to get all excited. Oh, there it is. No, because there's another piece to it. What's the other piece? What else do I have to do?
You have to find a determinant.
I got to do the determinant. So the determinant of the matrix is 2 times 1 minus 0 times 1. So it's this minus this. This minus this. So 2 minus 0 is just 2. Now what do I do with that 2? I divide all of these, the original matrix that you built, I divide all of those by the determinant. So my answer is 1/2, negative 1/2, 0, 1. That is the inverse.
Is that going to be on a calculator?
That's a no calculator. Remember, all this is no calculator till we get to the line at 40. James Blaine says, oh shoot, because my calculator will find the inverse. Oh yeah, it will, but you're not going to have a calculator. Okay, That was 30. All right, so I crossed out 32. So let's do another replacement problem for 32. The other replacement problem, there's only 2 replacement problems on the test. One of them is the circle that we just did. And then the other one is something like this. We have 50 kids. All right? All of them love music. Okay? They all love music. So I have these 50 kids out here, and I say, okay, how many of you like rock and roll? And 32 hands go up. And then I say, okay, how many of you like that rap stuff? And 41 hands go up. So then the question becomes, how many like, I'm not writing out there. See, how many like only rock and roll? Okay?
No.
Only rock and roll. Now, 32 kids like rock and roll, but stop. How many kids are in the room? 50. How many kids raise their hands? 32 went up for rock and roll. 41 went up for rap. How many is that?
73.
73 hands went up, but there's only 50 kids in the room. So what happened?
People voted twice.
There's overlap. There are kids that like both. How many kids like both? 23?
5. No, 23 is in the middle, 25 is for
Yeah,
rock and
okay,
roll.
yeah. I'm doing the middle. How many like both? Okay? So there's 73 hands that went up. There's 50 kids in the room. So how many people voted twice? 23. Now, there's a total of 32 kids in the rock and roll ball. How many are just right here?
11, 12.
Come on, how many? 9. Of course, 9. There's 32 altogether, right? If 23 of them are there, aren't there 9 here?
Yes.
How many are over here?
18.
18. Now we need to answer the question. The question was, how many like only rock and roll? 9
people only like rock and roll.
That's right. Thank you. 9 people only like rock and roll. All right, so that replaced 32. All right, so now we're ready for 34. All right, so 34 says we are going to multiply these 2 matrices. So it says find BC. That means we are multiplying them. I guarantee you one of the answers will be can't do. Because sometimes when we multiply, we can't. Can we multiply this one?
Yes.
Why do you say that, Max?
Because you can go, can you only go across?
What are my
Three.
dimensions here, Max?
3.
How many rows does this have?
2, 3,
3 rows.
and then
How many columns does it have?
it's 3 by 2.
It's a 3 by 2. All right, how many rows does this one have?
It's 3 by 1.
That's a 3 by 1. Can they be multiplied?
No.
No. Can't do. Can't multiply it because these 2 don't match. Can't be done. Right?
You can only multiply across like 3 times, or it has to be the same.
These 2 have to match.
Okay.
These 2 numbers have to match if they're multiplied. All right, so a problem that could be multiplied would be this. Let's suppose we wanted to do this problem. The one on the paper does not multiply. Would this one multiply? Well, let's see. What are the dimensions here? 3 by 2. What are the dimensions here? 2 by 2. Oh, now they match. So now we can multiply them, and our answer will be another 3 by 2. So 3 rows, 2 columns. So the one on the paper did not multiply. I'm doing one that does because we don't know what's going to be on the exam. All right, so to multiply now, I multiply row times column. So I take the numbers -1, 1, that's my row, times 1, -1, that's my column, and add them up. So it looks like that first spot right there, the first row and the first column is going to be -2. Now I'm going to take my first row times my second column. So I'm going to take my -1 and 1, and I'm going to times it by 2 and 5. So what do I get? Times 2 and 5, what do I end up with?
3.
3, perfect. Now I'm going to my second row, and I'm going to do exactly the same thing. So 2 and 0 times 1 and -1. So that's 2. And then 2 and 0 times 2 and 5. That's 4. Now my third row. 3 and 1 times 1 and -1. What is that? 2. And 3 and 1 times 2 and 5. And there we have multiplied. So if you can't do that, you need to practice. But the original problem didn't work. Always check your dimensions first before you try to multiply. Because you can't do it if those middle dimensions don't match up. Alright, so which one was that? That was 34, so now we're ready for 36. What do I do with that? Totally shifting gears. That's out of chapter 4 again. This was out of chapter 7. Draw my butterfly bow tie. Cosine. Cosine is what? Adjacent over hypotenuse. Very good. So I'm going to just label adjacent over hypotenuse. This side over here would be another one. And the angle is? So the answer to the question is 45 degrees. That's it. That's all there is to it. You recognize it's a 45, 45, 90 triangle. Now, 38. I use the longhand notation. That looks very, very scary, but that is the same as 3 CIS 10. CIS is your shorthand for cosine I sine. We talked about that, but I never really used the longhand. I always used the shorthand. So 3 CIS 10 times 4 CIS 15. How do we do that? It's easy. What's the rule? Multiply the R's. These are the R's. So we multiply those two numbers and we add those. So 12 CIS 25. Multiply the R's. This is polar notation. Multiply the R's, add the thetas. Easy. Number 40, I had to change the wording a little bit because we didn't do circular arrangements. So how many ways can 6 people be seated on a log? 6 factorial. That's right, 720, 6 factorial. When you're seating 6 people in a row, it's 6 factorial. Perfect. So we have just completed the no calculator part of the test. That is easy. Now the calculator part might be a tad bit more challenging. Let's see. 42. All right, our job is to find side A. Now this is a calculator, so use the calculator as much as you want. Our job is to find side A. By the way, on test day, remember, since you're not taking it with me, you got to make sure you have a calculator. All right, what's the first thing we want to do here?
Angle, side angle.
Well, it is angle, side angle. What, okay. What do you want to do with that information?
Put 78 over 80. I'm just playing. I don't know.
So I know this all has to equal up to 180. So
94 plus 78.
Okay, that's exactly right. So we got to find that third angle. We know the angles of a triangle are 180. So I think it's just 8. Tiny, tiny little angle there.
And then can't you do like a ratio?
We're going to do a ratio. It's called the law of sines, the law of sines. And we can do that because we have this pair right here. That's the key. So we're going to say sine 8 over 11.6 equals sine 78 over 8. Right? And then we will cross multiply. And remember, you're solving for A, so we're going to divide by sine 8. And I caution you when you type this in, when you do 11.6 sine 78, when you do that, a parenthesis is going to appear. You have to close it before you move on, so close the parentheses and then divide it by sine 8. I got 81.5. Is that what you got? Make sure I'm in degrees. Yeah, if you're borrowing a calculator from somebody, make sure you are it's in degrees before you get started, because those are degree measures. All right, now what about 44? 44 is a very similar problem. We're doing a triangle. But I want you to notice there's a humongous difference here. You don't have this. And if you don't have this, you can't do the law of sines. So this is going to have to be a law of cosines problem. Now, they tell me I am finding angle A. They tell me that in the problem. So that immediately dictates the way I'm going to set up my problem. Remember, in the law of cosines, it's that big long equation. And on one end of the equation goes the cosine of the angle that's involved. This is the angle that's involved. On the other end of the equation, all by itself, is 11 squared. Because whatever angle you've put on that end is the side you put on this end. Right? And then there's a whole bunch of stuff in the middle. Do you remember what's in the middle? 13 squared plus 9 squared minus 2 times 9 times 13 times the cosine of A. That's exactly right. That's the way the law of cosines works. Now Now, this is the tricky one to type in, so do it carefully. I would suggest that you just do, what I'm doing is just the basic arithmetic. So I'm just doing my squaring and my multiplying here to come up with that. Now, what would I do next to solve this?
Combine so add 169.
Absolutely. So 121 equals 250 minus 234 cosine. Now, there are going to be people that subtract these. And they're going to be the people that get the big red mark on the paper. These can't be subtracted. So what do? We're trying to solve for cosine. Subtract the 250. So we get negative 129 equals negative 234 cosine. And then so we have negative 129 divided by negative 234. And the negatives are going to cancel, right? So how do we find the angle then? We need the angle. That's not the answer. Second cosine. So we're going to second cosine that answer. And that's going to be angle A. So I got 56.5. Did I type it right? All right, so that was 44. So now we're ready for 40. Oh, nope, we got another crossed out one. I don't have a replacement for that one, so it's moving on. 48. We want to find the coefficient of the x4y cubed term in the expansion x plus y to the 7. Now we got a couple of different ways that we can do that. The band has to, they got a concert tonight. So we'll try to get out of here in time to all go see the concert. All right, so one surefire way of doing this is to write out Pascal's triangle. And we got to go all the way to the 7th row, but that's not as bad as we had to go all the way to the 10th row earlier. So the 7th row doesn't take long to get there. The numbers aren't very big, but you'll have a calculator anyway. All right, so there's my 7th row. I know that if I wrote out the 7th row, which I'm not going to do, this doesn't say do the whole expansion. But if I did, I'd have an x and a y next to everything, right?
Yes.
And in the first term, the power on the x would be 7. And then it would be 6, 5, 4, which is what I want. So there's my coefficient. So the answer is 35. So I wrote out the triangle and then I just counted down. Right? That's easy. That was 48. 50. Find the number of ways that 12 books can be arranged on a shelf that only has room for 7 books. So here's the deal. You have 12, but you have to pick 7 out of the 12, right? So that's going to be 12P7 or 12C7. I heard Emma Faulkner say P, and she is right. And the key word in there, kids, is arranged. When you go to arrange the books on the shelf, order matters, right? When you arrange things, order matters. Are your allergies bothering you? Do you have allergies?
Yeah, I got it.
Yeah, you look like your eyes are all bloodshot.
They are.
You look bloodshot.
My bad.
No, you're not terrible. You just look
Well, I mean,
like
it's because like I've been having like a stuff like I kind of have like a ear infection, and then it's like I'm having sinus, so I didn't know like what it was.
yeah. Well, I don't know what it is either, but it sounds like you might need to go to the doctor and get checked out.
Oh
This
no,
is
I
allergy
already
relief
went
from
to
Walmart. You'll be alright.
the Yeah. I'm just gonna write it out. I'll be back Monday.
Okay. Just ask the pharmacist back there. Okay. All right, that's number 50. So this is going to be a P problem. Now, you're going to type that in your calculator and get a number, and then that's going to be the answer. Okay? If you're still confused why it's a P problem, think about the shelf. Isn't this what the shelf looks like? And you have 12 choices for the first spot, and then 11, and then 10, and then 9, and then 8, and then 7, and then 6. So if that makes more sense to you, do it that way. That will give you exactly the same answer. 52. Find the height of a building if you are standing 100 feet from it. So here's the building, here are you, that's 100 feet, and the angle of elevation is 39. Now, does everybody remember the angles of elevation go here? Okay, and we want to know the height of the building, so it goes there. So then we write an equation, and our equation is going to use either sine, cosine, or tangent. So that one would be I heard cosine, I heard tangent.
No, it's tangent because there's an adjacent and then an opposite.
It's tangent. Here's the hypotenuse. Do I know anything about the hypotenuse? So we're not using sine or cosine. This is a tangent problem. So the tangent of 39 equals x over 100. And then we multiply by 100, so 100 tan 39 equals x. And 100 tan 39, I got 80.98. And I think that would be feet. Yeah. Oh, it doesn't even say. It just says you're standing 100 from it. All right, let's say it's feet. Okay? And now we have the word happiness. You just had this on your quiz. Almost everybody got it right, so we should be okay. What do we do first? Count them up. So it looks like 9. So we start with 9 factorial. Did I count right?
So this is where you can take 3 out. I thought you took like you said to 2.
I have 2 P's. 2 S's.
And that's it.
Is that it? Then when I type that in my calculator, I'm really, really careful about putting the denominator in parentheses. 90,720 is the answer. So that's a question we're all going to get right, right? All right, number 56. We have x minus 2 squared over 16, y minus 1 squared over 25, and we got to find the foci. Now this is an ellipse. Okay, so everybody knows what an ellipse looks like. Where's the center of it?
2, 1.
2, 1. So I'm going to start at the center. Then what am I going to do from the center? I'm going to count 4 over and 5 up. Now, I don't care what those points are, kids. You can label them if you want, but that's a waste of time. That's not what we're looking for. We are looking for the foci. Now, you do need kind of a sketch because you got to figure out whether the foci are going up and down or sideways. These guys are going up and down because this is the major axis. This one was longer than this one, right? So these red points are the points that you are looking for. And you would know exactly where they are if you knew how far up and down to go, right? You remember?
16.
Emma!
Do you do the square root of 16 or 25 minus 16?
That's exactly what you do. So the center to the focus is the square root of 25 minus 16. So Emma says I'm going to subtract my denominators. I'm going to take the square root. This one works out nicely. We get 3. So you're going to start right here at this point, which is 2, 1, and you're going to go straight up 3. So that would be 2, 4. And then you're going to go straight down 3. So this would be 2, negative 2. That's it. Those are the foci. Oh shoot, 58, we got another triangle. And we're finding B, so we're finding that. And we're finding the area. So we have 2 things to do on this problem. This is a 2-part question. Find B, find side B, find the area. Now, the area is the easiest one. Look at what you're given right here.
Side angle side.
Side angle side. And you have a formula for that. Area is 1/2 side times sine of included angle. So when you're given that information, as Max said, side angle side, you just plug it into the formula. 1/2 side, sine of included angle. So the answer would be 472.5.
Yes.
Easy. Nothing tricky about it, but you have to remember the formula. That's what's the hardest thing about this exam. Each individual problem is easy. There's no hard problems on here, but there's so much to remember. There's just so much to remember. All right, now we still have to find side B. So this is like our triangles that we were doing before. Do you have a pair? Do you have this, or this, or this? So if you don't have that, you're going to have to do the law of cosines. And the law of cosines puts the angle on one end. If you're doing law of cosines, you're only going to be doing one angle. There's only going to be one angle in the problem. So we're putting it out on the end. And then on this end, we'll go b squared. And then what's in the middle?
Oh, 38.
38 squared plus
32.
32 squared minus.
2 times 38 times 32.
Perfect. That's it exactly. Now because the variable's over here already, before the variable was back here and that was problematic, you can type this in a little easier. But you can take as many steps as you want to type it in. Like I said, this exam is short. Nobody ever has trouble finishing it, unless they just don't know what they're doing. The thing about this is, though, when you get it all typed in and you get it all this equal to something, remember you have to square root it. So the answer is 30.6. All right? And now we're ready for the mega problems. These are the megas. These are the two that you just can't leave blank. And on the multiple choice, are we going to leave any blank? No. No, that's just plain dumb. Answer yes on the multiple choice, right? And on the free response, try to draw a picture. Try to do anything that you can get points for. If you leave it blank, you don't stand a chance. Okay, so 60, problem 60. Now, I went ahead as I copied the problem and changed the pi over 2 into 90. Is that okay with everyone? And now I'm going to draw a picture of this, but I'm also going to list the amplitude, period, phase shift, vertical shift, domain, and range. And draw a picture. To get partial credit, at least, I'm going to draw the shape. Now I'm going to draw the actual picture here, but if I don't know how to draw the actual picture, I'm going to at least get the shape right. This is a sine curve, right? But boys and girls, you see that right there? That turns it upside down. So normal sines do this. This one is going to look like this, because when you put a negative out in front, it turns the picture upside down.
So is cosine the one that doesn't start in the origin?
Yep.
Okay. That's what this turns.
All right, so now I'm going to graph that in a minute, but first let's see what we can fill in here. What's our amplitude? 2. That number is the amplitude. So this guy is going up 2 and down 2. There he is. He's going up 2 and down 2. What's the period? 360. Because the period is 360 divided by that coefficient. That coefficient's a 1. So the period is 360. We had one earlier where there was a 5 there. So the period was 360 divided by 5. This one's 360 divided by 1. Phase shift, that's your horizontal shift, comes from the parentheses. This picture has been shifted how? How much? 90? Which way? Left. So this one has a negative 90 phase shift, or you can say left 90 if that makes more sense to you. So in other words, my sine curve that was supposed to start at the origin is now starting back here. So that is what my sine curve looks like. It's been shifted 90 degrees. It was supposed to start here, now it starts here. Okay? Now, what about vertical shift? Down 1. All right, so that means, I'll do it in a different color, that means every single one of these points is going to come down 1. So the actual answer is going to be the green thing. All right, what about domain? all reals. Mrs. Ford told you the domain of a sine or a cosine is always going to be all reals. It goes on forever and ever. Now what about the range? Look carefully. Think about the situation. When you told me the amplitude was 2, that means the thing is going from -2 to 2. But you took the whole thing and shifted it down 1. So instead of being -2, it's now -3. And instead of being 2, it's now 1. So your range is -3 to 1. Now, if I want to get complete, total, full credit, I need to also label these intermediate marks. Max?
Okay, where are you getting 3 and 1 from? Like, what did you do to get 3?
Okay, it used to be down at -2. When I drop it down 1, where does it go?
So it goes down -3.
There you go. And it used to be up at 2, but I dropped it down 1. All right, so my period was 360. That means I end 360 after I started. Now normally I would end at 360, but since I backed up 90 to start, where am I going to end now? 270. That's 0, so this would be 90 and this would be 180. And there we go. So, if you can do all that, you got mega points coming. You're probably, some of you aren't going to be able to get all of that, but at least you can get some of this, right? Some of this is so easy. Don't skip this problem. Fill in whatever you can fill in. Get the shape at least. Get what you can get in there. Okay, and then one more problem. This is another big one that you absolutely have to put something down for. Do not leave this blank, all these parts. Our points are 1, 2, and -1, 6. So the first question is, find the coordinates or the components, same thing, components, coordinates, same thing, of AB. What are you doing here? Going from A to B. What is it? -2, 4. She's right, right? Going from here to here and here to here, -2, 4. Second question. What's that mean? Magnitude. We already talked about that. That was in another question. How do we find magnitude? Square, square, add them up and take the square root. So that's a square root of 20, which is 2√5. Next question. Find the unit vector. How do we find the unit vector? This is so easy. Just remember how to do it. What do? We take this guy right here and divide it by the magnitude. So it's the coordinates of the vector, which are -2, 4, divided by the magnitude. And then simplified however you need to simplify it. So this particular one has some canceling that can happen. So it's -1/√5 and 2/√5. And then it has rationalizing to do. -√5/5, yep, and 2√5/5. There it is. There it is. And then we want a vector with a magnitude of 4. Well, that's so easy. If you want a vector, okay, think this is 1 unit long. If you want it to be 4 units long, you're just gonna take that guy and times him by 4. So negative 4 root 5 over 5 and 2 root 5 over 5. Remember, when we multiply by 4, kids, it's 4 over 1. So we're not changing the denominator, we're just multiplying the top by 4. And then we want the vector equation, but this is where I got so nice. I set this up for you. So you know that's what you're doing. You gotta fill in the blanks for this question. So what goes in the first parentheses? The original point, either one of them. Back to the original now, don't get confused. So I'm gonna use 1, 2. What goes in the second parentheses? Not the other point. No, not the other point. The vector, negative 2, 4. In the first parentheses goes one of the points. The other point does not get used. The other parentheses is the vector. Okay, that is not hard. Remember it. Take a note, remember it. Some of you are in a position where you have to get every point you possibly can. That's an easy one to get. Jalen, you gonna try to stay awake over there? Okay. All right, and the last question, what are the parametric equations? Well, we already did that once today too in a different question. That's when we split this up. So what is this split up as? X equals 1 minus 2t, and y equals 2 plus 4t. Right? Now, I want to just point something out. Here's question number 1, right? Find the coordinates. What happens if you miss that? They're all wrong, because they all use that, don't they? So take your time, well, on all the questions, but particularly on this one, make sure that you've got the right vector to get you started as you work through. Okay? Now, we have a few more minutes. Of all those questions that we just did, we have time to do a couple of repeats. So what kind of question does anybody have? Does anybody have something that you think, I just need to see that one more time? Who said something? I still couldn't hear. Oh, I'm not doing the whole thing again. No.
Well, can we do another triangle problem?
Yes, do you want to do law sines or law cosines? Find an angle, find the side, what do you want to do?
Give me anything because I need all the review I can get.
Okay, so let's do the 2-part triangle problem where we had something like this. And we had to find the area and we had to find side B. This was a 2-part problem. We had to find the area and we had to find side B. Area is easy. What's the area? 1/2 side times sine. SSS. Side times sine. Malcolm, if you weren't on your phone, you might understand more stuff. I don't care. I mean, you're not in trouble. I'm just saying. All right. So now, let's multiply that together. And we got 47.9. So if you remember how the area formula works, 1/2 side, sine, that one is easy. Done. Now we have to find side B. Now remember, when you're finding a side or an angle, you're going to use law of sines or cosines. So you look at the problem and you say, do I have a set? And the answer is no. So if you don't have a set, then you are going to have to do the law of cosines. And the law of cosines, remember, has the angle out on one end, so cosine 53, and then all by itself on the other end is b squared, because it's the one across from the 53. And then in the middle, I know Ryland knows, does anybody else know what goes in the middle here? 10 squared
Plus.
12 squared minus 2, 10, 12, cosine 53. And what am I going to warn you about when you type this in? Got to take the square root. We get so excited sometimes, we get this number and we do not square root it. So I got 9.98. I don't know if that's right or not. Is that what you got? That should be right, looks right. Okay? Alright, so one more problem. Emma?
I need you one of the problems to ask for the period.
Yep. So this is going to be a multiple choice question on the test as well as a piece of that big problem. But it's going to give you some equation like this. Okay? I'm just going to say, what's the period? Now, whether it's a sine or a cosine is irrelevant. The period of both starts out as 360. And then, if there is a coefficient, well, whatever, you divide by that coefficient. So this one would be 360 divided by 4, which is 90. And then along with that one, in the free response, there might be something that looks like this. And it says, what is the range? What is the range of that function? Now, what that means is, if you were to draw it, how far up and down does it go if you were going to draw it? Well, this is the amplitude, and that number tells me that I go up 4 and down 4. So unless I have added or subtracted something to the end, like this, that is my range. So my range would be -4 to 4. Okay? All right, let's do one more. Who's got one more? We just need to review real quick. There's a lot of things you don't know, people. So let's pick one.
How about the standard form? Get
Of-
the standard form.
Find the standard form of a line. So the problem will be written as a vector equation. So it'll say xy equals 3, 4 plus t times 5, 6, let's say. Okay? And it says, find the standard form of this line. All right, here we go. So x equals 3 plus 5t, and y equals 4 plus 6t. This is not the answer. Okay, please understand, this is not the answer. To get the answer, you have to get rid of the t. So how do we get rid of the t? We either substitute or we eliminate. Now, I don't like the looks of this substitution because it's going to involve fractions. So I'm going to go ahead and eliminate. So I got to multiply this one by 6 and this one by -5. Kids, you know how to do this. You are eliminating a variable. So I'm going to change those in the 30s. So 6x equals 18 plus 30t, and -5y equals -20 minus 30t. Now when I add them together, will I eliminate the t's? That's what I wanted to do. So I'll have 6x minus 5y, 6x minus 5y, those don't add together, equal to negative 2. And that actually is the standard form.
So would you give us full points if we left it like that, or?
It's gonna be a multiple choice question. So you just wanna make sure your answer matches one of the answers in the multiple choice.
Okay.
So this would be the right answer, but another form of that would be this. This is the exact same equation, just multiplied through by a negative. So you gotta recognize these two are the same thing. So if you got that, but that was listed as an answer, that would be okay,
Okay.
right?
No, you always like substituting for eliminating by that.
Always the t's. Always the t's. Gotta get rid of the t's. Your equation has to have x's and y's in it. Y equals mx plus b. That's the kind of equation you want.
Thank you, Miss.
Okay, now I want to give you a little bit of a heads up.